Hello geometry students. We got a very easy video today to start our new unit. This is video number 41. We're going to talk about factors, primes, and perfect squares. You might want to grab a calculator. You're probably going to need a calculator before this is over. Okay, so we're going to create factor tables for numbers, and then we want to review what is a prime number, what is a composite number, and what's a perfect square number, all of that. Okay, this won't be so bad. To find all the factors of a number, it's very convenient to make a table. So start by making like a T-chart. We're going to find all the factors of 30s, and factors come in pairs. Every number has at least two factors. It always has one in itself. So on the left column, I write the first factor. The second column, I write the second. 1 times 30. Another way to factor 30 is put in 2. 2 times 15 is 30. So I got 2 more factors. And it's kind of a systematic way. I keep going up and trying numbers. Does 3 go into 30? And sure it does. 30 divided by 3 is 10. So 3 times 10 is 30. How about 4? When we do 30 divided by 4, I think we get 7.5. So 4 doesn't go into 30. 30 can be divided by 4, but we don't get a whole number back. And we're looking for whole number factors. How about 5? If we put in 5 into 30, 30 divided by 5 is 6. So that's why you need a calculator to see if numbers go into the given number. Then, does 6 go into 30? It does, but I already have a 6. So I stop when I start repeating myself. So I could put a 6 here, but then I get a 5, and we already have that. So 30 has 6 factors. The factors of 30 are 1, 2, 3, 5, 6, 10, 15, and 30. I wish I could count. I think I said 6 factors. It has 8 factors, so 8 factors there. Okay, let's do 17. Okay, 1 goes into 17. 17 divided by 1 is 17. 17 divided by 2 is 8.5. 17 divided by 3 doesn't work. 17 divided by 4 doesn't work. 17 divided by 5 doesn't work. In fact, nothing else works. This is it for the factors of 17. It only has 2 factors. When a number has only 2 factors, it's prime. So a prime number, one way to think about it, is a number that has exactly 2 factors, 1 in itself. Let's move on to 48. 48 has a bunch of factors, so I know to make the table big. Well, we always start with 1 and 48. 2 goes into 48. 48 divided by 2 is 24. 48 divided by 3 is 16. 4 goes into 48. I'm starting to think everything goes into 48. 4 and 12. 5 doesn't go into 48. 6 does. 6 times 8 is 48. 7 doesn't go into 48. And when I get to 8, I'm back to something, a number I already have. There is a way to tell when you can stop guessing. You can stop guessing when you go past the square root of a number. Square root of 48 is, let me find it here, 6.92 something, or about 6.9. So about 6.92 something. So that tells me I can stop actually when I get to 6. So on the left side, I keep going up by 1, trying numbers. And I can stop when I go past the square root of 48. So I don't need to really try 7 because that's past the square root of 48. So it's kind of nice to know when to stop. If you have a big number, well, when can I stop trying things? Okay, 48 is definitely not prime. It's composite because it's not prime. Any number that's not prime is known as composite. Okay, 16. Here we go. 1 and 16, 2 and 8, 4 and 4. And actually, I could stop because square root of 16 is 4. 16 is an example of another kind of number. 16 can be written as 4 times itself. Any number that can be written as a whole number times itself is a perfect square. When we talk a lot about square roots and perfect squares, and I thought I'd bring up factor tables because one way to look at it, we're going to look at it a different way in class. So which numbers are prime? There's only one, 17. Which numbers are composite? Any number that's not prime. So 30, 48, 16 is 2, even though it's a perfect square. Either you're prime or not. So if you're not prime, you're composite. So 16 belongs there too. Which numbers are perfect squares? 16 was a perfect square. All right, let's keep going. Here we're going to practice some more. So really kind of same question, just a little bit more practice. We'll go through this one a little bit more quickly. I got something for you to do. So 51. All right, we can start with 1 and 51. 2 doesn't go into it, but 3 does. 3 times 17 is 51. 51 divided by 4 is a decimal. 51 divided by 5 is a decimal. I might start wondering how high I have to go. Square root of 51 is 7.14. So I can stop when I get to 7. So 6 doesn't go into it, 7 doesn't go into it. I know I can stop. I've reached all the factors. So 51 has 4 factors. All right, 21, that's a pretty familiar number. 1 and 21, 2 doesn't go into it, 3 does. 3 times 7. 4 doesn't go into it, 5 doesn't go into it, 6 doesn't go into it, 7 doesn't go into it. We're done. It has 4 factors also. Okay, 64. 1 and 64. 2 goes into it. 2 and 32. 3 doesn't. 4 does. 4 times 64 divided by 4 is 16. When can I stop? I can stop when I get to the square root, which is 8. So I gotta go up to 8. 5 doesn't go into it. 6 doesn't go into it. 7 doesn't go up to it, into it, but 8 does. And 64 divided by 8 is 8. Oh, I see it has like repeated factors. 8 times 8 is 64. Okay, so perfect square. All right, 41. There we go. We got 1, we got 41. 2 doesn't go into it. 41 divided by 3 is a decimal. 41 divided by 4 is a decimal. 41 divided by 5 is a decimal. Well, I might want to check the square root. Square root of 41 is 6.4. So I only had to go up to 6. So 5 doesn't go into it, 6 doesn't go into it, we're done. The only factors are 1 and 41. So it's prime. 41 can only be factored as 1 times 41. Okay, which numbers are prime? 41. Which ones are composite? Everybody else. And we had one perfect square again, 64. Okay, I told you this would be short and sweet. Here's the journal entry. I got 5 numbers for you. Please find the factor tables for all the following numbers and do the same thing we did in the examples. Which numbers are prime, which numbers are composite, and which ones are perfect squares. Okay, see you in class.